So variance. The next parameter is that, we need to go over understanding the variance. Okay. What is the use of this one? Okay. See, in case of variance, the main use of the variance is that, and it can help you like, how we can measure that, how it can be spread. Okay. And how the data it was spread around the mean, spread out of the data. And so around the mean that we can easily calculate it with help of the variance. Okay. So basically, the variance formula, it could have a very simple thing. It was sum of each and every data point minus, okay, and your original mean whole square, by n. This is the formula for calculating the This is the formula for calculating the standard deviation. So here, for example, I can give you like what exactly this term. This is like mean. See, basically the variance, we have a two type of variances are there. So we can calculate the variance for the sample, and we can calculate it the variance for the population also. Okay. So you need to remember these things actually. So for example, when we are talking about population, or when we are talking about sample, so let me talk about sample first, and then I could talk about population. Okay. So here we have various statistical measurements are there. One is like mean. Okay. When coming to the mean, so in case of sample, the variable we can represent it with a small x. And in case of population, the data variable we can consider the capital X. Okay. So the mean we can represent it with a small bar, and the mean of the population we can represent it with you know, what it is? Mu. Okay. Mu indicating that it's a population mean, and small bar indicating that it's a sample mean. Okay. The next variable, or the next parameter is a variance. When coming to the variance, when coming to the variance, no, we can represent it with a capital S square. And in case of population, we can represent it with sigma square. Okay. And we have one more parameter that's known, it could be like standard deviation. When coming to the standard deviation, so we can represent it with a capital S, and but in case of population, we can represent it with sigma. Okay. So these are the three. Now these are the three parameters. These are the three parameters we need to remember actually. So most of the time we are going to be using these things only. For example, in case of sample, how could I calculate the mean value? Tell me what is the mean, what is the mean of um, sample? What is the formula for mean of the sample, and what is the formula for mean of the population? Tell me, guys. Very basic thing. That's the question. Tell me. Hmm? Okay. See, I'm taking that, formula for I have a data something like this. Okay. This is my data for the sample data. Okay. One, two, and just 1 second. So here, so I'm taking the some sample example. Okay. So one, two, three, and four, and 5 something like this. Okay, I would like to go for calculating the mean of the sample. Then it's a very simple thing. Sum of the elements by the total number of elements minus 1. So here we have the 5 elements are there, right? So 5 minus 1, it could be the 4. And 1 plus 2 plus 3 plus 4 plus 5. How much? It's a 15, right?
Yes.
Right. Okay. And so tell me what is the value it is. So 15 by 4. 3 times. And 7 times. 5 times. Is it correct or not? Maybe if I'm wrong, so calculation wise it could be wrong. Okay, but this is the way of approach to calculating the mean of the sample. Okay, but the same thing I'm considering as the population data. Okay, this is my population data. I did one particular experiment. I got the values something like 1, 2, 3, and 4 and 5. Okay, this situation, I would like to go for calculating the mean. The mean we can represent it with mu, and so here we have the 15 by 5, and you will be getting that mean. So calculation 15 by 4. That's correct on it. Okay. Yep. So here we got that mean value is the 3, right? Okay. Here we have a same data, and here also we have a same data, but this is the sample mean, and this is population mean. So the difference is what? Sum of total observations by total number of observations minus 1. That is the formula for the mean, and total sum of observation by total number of observations, that we call it a population mean formula. Okay. I hope if you clear this particular point. And this is needed action. So don't think to sample and population formulas are same. Both are different. It is not at all same anymore. Okay. Some situations. No, I'm talking about the variance, right? When I'm talking about variance, and the variance also, it could have the two things. One is for sample and one is for population. Okay. One is for sample and one is for if I have the population data. So I already told you the representation part, this could be the S square, and this we can represent it with the sigma square. Okay. So tell me guys, what is the formula for this one?
Sum of samples by number of samples.
No, I'm talking about variance. Sigma square. For example, if you have the X, they have like, each and every member we can like, you can call it as the X1, X2, and X3, and so on. You have the Xn. Okay. So that you can start with 1 to n. Okay. So each and every member we can represent it with I, right? So xi minus what is the mean value? You already know that how we can calculate it, the mean, right? For this population. So mean of the population whole square by, okay, total number of population size. This is the formula for this is the formula for population variance. This is the formula for population variance. So tell me for sample variation formula.
Think the second value minus the first value. Yeah,
Hmm?
I mean, like x2 minus x1. by number of values. By number of values.
It is also similar like
I'm
no
not sure,
mean.
but just I'm predicting.
Yeah, yeah. So s square. So the formula for this one is, for example, if this is my x variable and it could have some kind of data members or x1, x2, and x3, and so on, we have the n number of samples are there. Okay. So the formula for this one is, okay. So for sample variance is, it could like sum of, it could start with 1 to I value, right? So I value which is start with the n to 1 to n, and each and every data member, it could be subtraction with the sample mean. So you know that how we can calculating the sample mean also. Sample mean by total number of the sample size minus 1. This is the formula for, so square term. So I forgot to mention the square term. Okay. So this is the formula for sample variance. Okay. Clear, right? So, so don't think, don't worry about these formulas, and you don't need to remember also, but there could be some kind of variation is there for sample formulas and population formulas, and you can try to remember it, or else, it's a basic thing. Say you can easily remember it actually. Okay. So with help of this one, you can easily, spread out the data, how the data is spreading around the mean, that you can easily calculate it. But in case of variance, because of the square term, even we have the small difference is there, you will be getting the lot of difference actually. Let me take a small example. Let me take a small example. And this is my x data. This is my x data, and which is 1, 2, 3, and 4. I would like to go for calculating the variation. Okay. So for calculating the variation, first of all, I have to calculating, this is the sample data, guys. Okay. So, or else you can call it as the population. It's up to you. If I'm taking the population, the formula, it could be changed. Instead of the s square, it could be sigma square. So what is the mean? What is the mean of this particular population? 1 plus 2 plus 3 plus 4. How much? 6, 10. Okay, 5, for example. So 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15, 15 by 5. It's a 3, right? So this is my mean. So I want to calculating this value, right? Before I calculating this value, so I would like to go for calculating the xi minus mean. So xi minus mean in the sense 1 minus 3, it's a minus 2. And 2 minus 3, it's a minus 1. And 3 minus 3, it's a 0. 4 minus 3, it's a 1. 5 minus 3, it's a 2, right? And I can apply the square term xi minus mean whole square. Okay. So minus 2 whole square 4, 1 square 1, 0 square 0, 1 square 1, and 4, 2 square 4. Okay. After that one. And I would like to go for calculating that, sum of xi minus mean whole square, right? So what is the value of this one? So 4 plus 1 plus 0 plus 1 plus 4. How much? 4 plus 4, 8. 8 plus 2, how much? 8 plus 2. 8 plus 2, 10, right? Guys, are you getting my
Yes, sir.
voice or not? So 10, right? Okay. So now the formula for the variance is sum of xi minus mean whole square by n. So the value of this one is 10. And so how many number of elements we have it? It's a 5, right? So
5.
my mean value is 5. So 10 by 5, it could be the 2. So here my standard, variance is 2. Okay. Here my variance is 2. So this is the way you can calculate it. But because of the formula, it could have the square term, right? Because of that one, maybe if we have the small variations there, you will be getting the larger value. Okay. For example, if the difference is 10, so 10 square in the sense, it could be like in 100, right? Okay. And if I have the 100, so 100 square, how much? It could be some value like, 10,000, right? Is it clear or not? So there is some kind of, even we have a small variations there. Okay, you will be getting that, the result, it could be like, a very large. So to overcome that one only, we have the second type of, to calculating the second, to calculating the how the data is spreading and to measure that how the data is spreading. To calculate it, that one, we have another thing, which is the standard deviation. Okay, so that which comes to the standard deviation. So coming to that standard deviation, it's a very simple thing. What the formula we have it for standard deviation, sorry, variance, and we just need to apply the square root for that. Okay, so that simply you can say that yes. So when it is a yes, the formula for this one is sum of xi minus x bar whole square. Okay, and by n minus 1. This is the formula for the standard deviation for the sample. And when it comes to the standard deviation for population, standard deviation for the population is 1 to capital N and xi minus sample mean whole square by capital N. So this is the formula, nothing else. First we can calculate the variance, then we can apply the standard deviation square root for that. Okay, so that we can reduce the that larger value to the smaller value. I hope you clear what exactly the use of the standard deviation. Any questions? Any questions?
On, on. Actually, so we should learn that the terminologies also.
Mm-hmm.
We will go through the first one. Why?
Yep.
Because what you are using the terminology, even they are not compatible as of now. So you should know that one.
That actually
Like
I'm
standard deviation.
that it could be okay. Okay, fine. So that is the
Yeah,
basics
yeah.
of
You told
statistics.
right, yes.
Yeah. So basics of statistics, but don't worry, you will get to know that everything. Okay. So once if you started learning of open any one of the website articles and go and read it, then in a few days only we can understand. Okay.
Yeah, it's actually in the 10th and intermediate standard, the plus two standard, we know this one, but
Yes.
we forgot that exact formulas and all. I will revise it once again. Get to-
Yeah. By the time of that might be we are in like intermediate state. We don't know the what exact importance of the statistics, so we neglect it. But actually, the importance of
Yeah,
the
so you are right.
statistics, the importance of the statistics very, it's very very important actually. Okay. So
At
what
that time,
exactly you can
actually, we learn only to get the marks only, to gain the marks. Now we are understanding that the importance of the probabilities, everything. It is there,
in my
very important. Yes.
yeah, in my screen, what you can see in my screen, whiteboard only, right?
Some formulas we can see.
Yeah, in
Theoretically,
whiteboard. Yeah, well, okay,
yeah, the
fine.
whiteboard, yes, whiteboard.
Now you can see my Excel. Okay, so here, what I can do actually, I would like to go for whatever I explained you so far. I would like to give you that formulas in Excel. Okay, some situation you have to handle in real time. You have to go for handle Excel also. Okay, it's a mandatory know the time in Excel. Okay, I want to teach you like in Excel, and so go and open that Excel sheets and doing some formulas, and it could be if you go and some handy, then in real time you can easily handle any kind of task. Okay, in terms of Excel, but the same things we can do in a Python and R, and before we do any coding and before we do apply anything. So for the first step is that we can do some kind of analysis on Excel only. Okay. Okay, fine. Let me try. So I'm considering the price is mine. Okay, Sam population. Okay. Okay. So I'm taking like mean of the population. Mean pop. Okay. So mean population is how can I calculate the mean population? So average. Okay, fine. Now let me go ahead and finding the variance. Okay, variance population. If you want to calculating the variance population in Excel, so you can have that where P is there, right? So we can see where dot P, and we can give that a data. Then it could give you like, this is the variance. Okay, it's a large variation is there. So which means that there could be a lot of differences there with your real data. Okay, so that let me go on. So for the same thing, I can use that variance for the, if I'm taking that data is my a sample. If I'm taking like the data is a sample, then what is the value we'll be getting? Let me see. Whereof dot s. Okay. Okay, this there could be some small variation is there, not too much. See, here 62664, but here 64633. Small variation is there, right? And same thing we can do that to standard deviation. So here the values are, it's a very high values. So maybe even you have the small variation is there because of the square term, it was increasing a lot. Okay, so that's the reason we are doing that standard deviation. STD be a population. For example, I want to find the standard deviation of the population. Then simply you can give this data. Okay, you don't need to go on doing that. See, it was reducing, right? It's a 4611. It's very high, but it was reduced to some value, right? Okay, very minimal value, right? But within this range only, right? So that is the importance of the standard deviation. Standard deviation of the sample. Let me go on finding that standard deviation of sample. Okay, almost same. Any question? Any questions? Even you are taking the population and sample, so the parameter and the results and the statistical values, it could be a small variation, not too much variation. Okay, right. So this way, with help of the range, min, max, variance, standard deviation, and interquartile range, and with help of that one, so you can easily recognize and we can easily find that how the data is spreading around the mean, that you can easily calculate it. Okay, I hope I hope you clear. I hope I clear your all points. And if you have any question, please let me know. I would like to try to answer your questions. Okay, so no, let's go for finding that box plot. So it's a visualization data. How it's needed for all of you. Like when you're talking about data. So with numbers, it's very tough to understand and it's very tough to analyze the data. Okay, so that we have various visualization techniques are there. So let's go for understanding that visualization techniques over here. And in yesterday's session, I explain you something like interquartile range and phi summary data, right? That particular phi summary data we can represent it with a plot. That plot we are calling it say box plot. Okay, so box plot sometimes we can call it as the whisker plots also. Okay, so this box plot or whisker plot will help you for for showing that the entire data in 5 elements. with the min, max, and the third quartile and first quartile and median in a graph format actually. Okay. So how the data could be looks like, it's very for understanding that one. Here we have a insert operation is there, and go and find the chart. So you can go and see that the graphs where that scar plots are there, and we can. Yes, I am not needed this one, and yes, here we can see. You can see this plot, right? This is the plot we are calling it, say, whisker plots or box plot. Okay. See what it could be there. So this is your max data. Okay. So this is your max data. Okay. And the next one is, this is your minimum element. This is your minimum element. Okay. And so this middle one, we have it, right? First, I can explain this thing. Clear all arrays. And let me try this one. Okay. Yep. So this is your small value, 0 Kotlin. Okay. This is your this mm, it is not correct. Okay. Anyway, so you can see this plot now. This data, right? It's whatever the data which is out of this line. That line we are calling it same. That line we are calling it same outliers. Okay. With help of this box plot, we can simply find that what are the outliers are there in your data, and how many outliers are there also we can easily calculate it. And if it is very minimal number of outliers are there, we can easily calculate it. Okay. So for looking this kind of plot, we are calling it a box plot or else whisker plot. And this is like 1 point q1 minus q1 minus 1.5 q1 minus 1.5 IQR, right? So this line, this bottom line, this bottom line is q1 minus 1.5 into IQR. That's what I explained yesterday, right? Yes or no? And so this is exactly your median value. Okay. And this is your one q3 plus q3 plus 1.5 IQR. Okay. And last we have it's a max value. So what the data we have it greater than the q3 plus 1.5 into IQR, particular data we are calling it same. That specific data we are calling its outliers. What the data which is less than the lower whisker, and that we are calling it same outliers. But fortunately in our data in a lower whisker, we don't have any kind of outliers. That's the conclusion of this particular graph. Okay. Any questions so far? Hello.
No issues, sir.
Okay. So you can try to go and find these things, and by tomorrow we'll continue our visualization things, and we'll finish at the visualization point for tomorrow session and go and practice it. Okay. And see, I'm giving a lot of time to you guys, and go on. So if you simply neglect this time, then it won't help you in a time of when we are building some kind of machine learning. Okay. So you won't get enough knowledge. Okay. So thank you so much for your time, and we'll meet by tomorrow session. So I think tomorrow we don't have session. We'll meet on Monday. Yeah. Bye. See you.
Yeah, okay.